Hi, everyone. Well, I was wrong. I'll I'll take that. I was wrong. That's fine. I'm gonna go through properties of rhombi and squares. It's not rhombi are a little bit different than squares. Let me show you real quick. For you've got your parallelogram, right? And then like one of the kids of a parallelogram is your rectangle. Now a different kid of parallelograms is going to be rhombi. Okay, so a rhombus does not do all the things that a rectangle does. In fact, it does none of the things a rectangle does. However, a rhombus does do all of the things that a parallelogram does. Just like how a rectangle does all the things that a parallelogram does, a rhombus does all the things that a parallelogram does. So, right here, it does all the same things that a parallelogram does, so the opposite sides are congruent, the opposite sides are parallel, and so on. And it also does two more things. Or I'm sorry, whoa, that's three. That's three more things. This time, all sides are congruent. Congruent. So that means that like down here, JK is the same length. Right here, JK is the same length as ML. We already knew that, but it's also the same length as KL and JM. It's kind of like a square, okay? It's kind of like a square. All the sides are the same. You'll notice, though, that it's still lopsided. Like this guy's leaning to the right a little bit, and that means that those diagonals are no longer congruent, okay? Those diagonals are no longer congruent. They still bisect each other, but they're not congruent anymore. Okay, so we don't have all those nice isosceles triangles on the inside anymore. I prefer rectangles personally. The thing that we get though, when we, what's it called? When we take all the sides of a parallelogram and make them all the same length, is that the diagonals are angle bisectors. Bisectors. And what that means is that this diagonal is going to come on up and it's going to cut this angle in half, which means that now you've got two congruent angles right there. That's that. There you go. The last property is a bit of a weird one. The diagonals in the middle, they actually intersect perpendicularly. So the diagonals intersect perpendicularly. So that means you have all these 90-degree angles in the middle there. Okay. So coming down, you've got JK is 12. You've got JN is 7. I'm going to put that on that side. And that means you can actually find all the lengths on the outside. You know what JM is. You know what ML is. They're all going to be 12 because that's one side of your rhombus right there. JL is the whole diagonal. Now, the diagonal is still being cut in half. And if the diagonal is being cut in half, that means this is half of it, which means the whole thing would be double that, 14. Oh, let me see if I can erase this precisely. There we go. Okay. Oh, there we go. Now for MN, we have to work a little bit harder. That's this length right here. It's not a rectangle, which means your diagonals are not congruent, which means you cannot just say, oh, this length is the same as JN. I wish it were true, but it's not. That's a different shape. We'll talk about that probably tomorrow. So from here, we actually have to, oh, you're going to love this. We have to use the Pythagorean theorem again, okay? But we have to be, move, please. We have to be careful about how we go about doing it because we're looking for MN, that's this length right here. We know this length is 12, and here is our right triangle. Let me actually move that a little bit better, like over here. So this MN right here is a leg of your right triangle. Here is your right triangle. So let's call it x. You've got x squared plus 7 squared is equal to 12 squared. So x squared plus 49 is 144. And then x squared is equal to, what is that, 95? Uh-oh. Nope. We're going to check. Don't trust me. 144 minus 49 equals 95. And we got to take the square root of that. So you got to take your square root. You get x is equal to, boom. 9.7. There we go. So this is 9.7, which means the whole thing, this whole length right here, MK, is going to be 19.4, right? You're just going to, you're just going to double this length right here, 19.7. So you do have to keep using Pythagorean theorem, right? Those right angles keep showing up. You keep on having these right triangles on the inside of your figure. Don't panic about it too much. It's not the worst thing we've done. EF over here on number 2 is 23, and DF is 40. Right? DF is 40. That's a diagonal, so I'm going to label that there. If we know EF is 23, that means GF is also 23. With a rhombus, all the sides on the outside are the same. So, for HF, that's half of this diagonal right here. That's this half. The whole thing is 40, which means the half is the 20. And then we need GH, and predictably, right, we need that. We know that's a right angle. You have Pythagorean theorem again, so you've got x squared plus 20 squared is equal to 23, or is equal to 23 squared. So you get x squared plus 400 is equal to, something, I bet. 23 times 23 is 529. Gotta know your squares. And then you got x squared is equal to, right, subtract your 400 from both sides. You get 129. And then take your square root. Now this should be about 11 something. Let's see. Where's my clear button? There we go. 129 square root is 11.4. That's 11.4. And now that you have this piece of your diagonal, the whole diagonal is just 2 of those guys. So it's going to be 22.8. 22.8. Excuse me. And we're just going to keep going from there. If you have questions while you're doing this, let me know. For number 3, you know that the length of your diagonal RT is 22. So come on down. RT is 22. And then US is 18. Let me highlight that a different color. US is 18. So only given the diagonals, you can actually find all the other sides. VT, well, that's half of your first diagonal, so that's half of 22. And UV is half of your second diagonal, which would be 9 this time. So let's actually write those in real quick. VT is 11. UV is 9. You have your right angle there. So if you want RS up here, that's the same as UT down here. Those two are congruent. So let's find UT because we have our right triangle right there already. And then we can go ahead and set up Pythagorean theorem. 9 squared plus 11 squared is equal to x squared. That's 81. That's 121. That's x squared, which means x squared is equal to 202, I believe. And the square root of 202 should be 14 something. Right? Let me double check. 81 plus 121. I'm just making sure. Yeah, I'm not crazy. And then take the square root of that. You end up with 14. Right? Take your square root, take your square root. X is equal to 14.2. 14.2. And that's RS. Now ST down here is the other side, which means it's also congruent. So that's 14.2 as well. Now, those are all the side lengths. If you've got questions on the side lengths, let me know. But for number 4, we're going to start focusing on the angles. Now, when we're looking at these angles here, the important thing to remember is that every single angle in the middle is a 90-degree angle, and then all of these angles made with the diagonal, where the diagonal is coming in and cutting that side in half, all of these guys are going to be the same to each other, okay? To each other. We're not going to have an instance in a rhombus where like 6 is congruent to 5, okay? Because that would require that you have an isosceles triangle here. You do not have an isosceles triangle here, unfortunately. That would be a rectangle, which we'll get back to that tomorrow. For number 4, you've got this angle right here is 38 degrees. Now, what I like to do with these, I like to jump around, only because some information is like kind of given to you, like number 8. Number 8 is 90 degrees. Number 8 is 90 degrees, done, right? You don't have to go in order. In fact, I don't really think you should. And from there, I'm just going to keep going. Right? If we know 38 is 38 degrees, then we know 3 is also 38 degrees. Now, the nice thing is that when you are dealing with a rhombus, what you can do is you can take this like half of the rhombus and you can overlap it going that way. So you can take this piece and overlap it with this piece, and all the pieces line up. Okay? You can still flip it horizontally on itself. That is okay. Which means you know what angles 4 and 5 are already, because they're the same as 3 and 38. They're the exact same thing. All of those are 38 degrees. 38 degrees and 38 degrees. The other thing would be, now that you know 5, you can get 6. Because you know what 5 is and you know what 8 is. It's 90 degrees. So that means you have two options here. You could either say, okay, 5, 8, 5, 8, and 6 all add up to 180 degrees, or 5 and 6 just have to get to 90 degrees because this is already 90 degrees, and that's how you're going to get all the way to 180. So for 6, we've got 90 minus 5 is 38 degrees, and 90 minus 38, I'm having a slow morning this morning, 52 degrees, there we go, 52 degrees, which means 7 is also 52 degrees because they're right next to each other. Right, they're right next to each other, which means they have to be the same. And that means that 1 and 2 are also both 52 degrees. I'm going to stop there. If you have any questions, let me know. If you have any questions on the rectangles homework, also let me know. I'd be happy to help. Send me an email. I'll be here. It says from 9 until 2. Email me whenever. I will answer you, or I will get back to you tomorrow if I don't answer you today. Otherwise, I hope you have a good rest of your day, and I will see you tomorrow, because I will see you tomorrow. I'm not going to be wrong 2 days in a row, I promise. Bye-bye.